Hey, and welcome to assignment 3. The main focus of assignment 3 will be the analog signal conditioning peripheral, also known as op-amp. The op-amp peripheral consists of 3 operational amplifiers, or op-amps, 1 resistor ladder per op-amp, as well as multiplexers to create a wide variety of op-amp configurations. The objective of assignment 3 is understand the necessary step to configure an op-amp, configure op-amp 0 as a voltage follower, and plot the input and output of op-amp 0 using the data visualizer. First, let's have a look at what a voltage follower is. A voltage follower is an op-amp configuration where the output is equal to the positive input. This is useful for creating voltage buffers. The voltage follower configuration is achieved by directly connecting the output of the op-amp to the negative input as shown in this picture. So let's see how we could do this in code. Alright, so here we have the op-amp init function where we'll initialize the op-amp peripheral. So the first thing we need to do is to set the time base. The time base need to be set so the op-amp peripheral is aware of how fast the clock is for its internal timings. So the way this works is that the time base register should be set to the number of clock cycles needed to create 1 microsecond. And there are some special rounding rules. So if the number of clock cycles to create a microsecond is an integer, then you should take that integer -1. But if the number of clock cycles to create a microsecond is some kind of float, you should just round it down to an integer. And this we have achieved through the macro up here. Then the next thing we need to do is to set the output mode of the op-amp and to turn the op-amp on. The output of the op-amp can be disabled and the op-amp itself can be disabled, and this can be turned on either through software by setting these bits, as we are doing right now, or they can be turned on by events. The next thing we need to do is to configure the multiplexers of the op-amp to create the voltage follower configurations. So here we see that we will connect the output of the op-amp to the negative input of the op-amp, exactly as we showed in the picture previously. The second thing we will connect the positive input to the DAC, because the DAC will be providing the input to the op-amp for this example. As there is no need for the resistor ladder in this example, the resistor ladder can just be turned off and set to its default value. The next thing we need to do is to set the settling time of the op-amp. So generally speaking, if you don't know what the settling time should be, the safest thing to do is to set it to the max settling time, which is achieved by writing 0x7f into the settled register, which is achieved by this macro up here. Then we just need to enable the entire op-amp peripheral, and then we just have to wait for the op-amp to settle before we can go onwards in the program. So let's take a look at what the rest of the program is doing. So we are using the DAC to create a sinusoidal wave as an input, and we're using the ADC to sample the output of the operational amplifier, and all this data, both the output from the DAC and the measurements from the ADC, is streamed over USART to the data visualizer. So let's flash this program and have a look how it sees in the data visualizer. So here we have the data visualizer. Each of the assignments that use the data visualizer come with a pre-made workspace. So the first thing we need to do is to load this workspace, and then we will select assignment 3.json. This is assignment 3. Then you will see it will set up the graphs and everything we need. And then we have to go to COM here to start the user communication. You have to set the baud rate. The baud rate for each example in this training is 115200. So we have to apply this. Then we can start the user communication. Then we have to connect the decoder to the USART. So the decoder can decode the data that we're sending from the AVR DB to the data visualizer. And then we can start showing some live data. And if we pause this data, we will see that the red line is the input to the operational amplifier, or the output from the DAC, while the green line is the output from the operational amplifier. And as expected, we can see that the input and output follow each other very closely. The main goal of a voltage follower is that the output should be equal to the input. That's it for assignment 3. Thanks for watching.